Hello everyone, and welcome back to another episode of Let's Code a Mining Turtle. This is Selek, and when we left off, we had added some functionality to our excavate function here. If you remember, we added this depth idea. And when we left off, I talked about working on the next function I want to work on, which is a little more complex, and we're going to call it goToPosition. And let's go ahead and just rough it in right here. And let's see, goToPosition. And this is going to have a function with some helper functions local to it inside of the, let's give it parameter and end. Okay. So the idea for this function is that we're going to provide a position. I remember last time we made our position into a table. And the position contains a X, Y, Z, and a direction, which way the turtle is facing. So we're going to be able to give this thing a position, and this is the position that it's going to want to go to, or that we're going to want it to go to. Now, another thing we're going to add is the ability to specify the order. So if we want it to go in the X direction first, the Y direction first, or the Z direction first, we will specify that here. And if it can dig to get there, because especially in a I guess fully functioning world, you might have pipes and some advanced machinery that you don't want the turtle busting up just in case. You want to be careful. Or you may be in a new world and you want to be able to dig wherever you want to go. If you want to go through a mountain, you can do that. So that's going to be a Boolean that we can pass to the function to tell the turtle what to do or how to do it. Okay, so what we're going to do first is we're going to go ahead and start and give it, we're going to have a sort of a while loop that we work on. But so to do that, we're going to say, hey, is this finished? This is going to be our first little Boolean value. And since we're starting off, we know it's false. And then we're going to see now. So order and can dig are going to be optional values. So you don't have to pass them in if you don't want to. And if you don't, so if order is nil, then order, we're going to give it an order. And we're going to say X first, then Y. Then Z. Nope. Sorry. Z next. Z. Then Y. Y last. Okay. And let's end that little if block there. And if can dig is nil, then we're going to say can dig is false. So that, well, we don't want it digging someplace if we forget to pass it in. All right, so there we go. Now what we're going to have some helper functions to help us do what we want it to do. So one of the helper functions we're going to have is it's going to be a local move X, a local move Y, and a local move Z. And we're also going to have a rotate. It'll be a local rotate. Because we're going to be able to rotate it to go in the direction we want it to go. Okay, so now that we have our local variables and our order and can dig values taken care of, we are going to call these move functions in a specific order, the order given by the table order. So to do that, we're going to have if function in order. So if the F in order, so the first one it goes to, and I said this wrong, F4. So this is sort of like a for loop. So it's for every, we're going to call it F, for every little item in order, we're going to do something. We're going to check if F is string.lower X, then we're going to call move X. else if f is string dot lower y, then we'll move y. Lastly, else f is string dot lower z, then move z. And let's go ahead and go back and end that, and let's fix the indents here. Okay, and we'll line up our little block here. And let's see, so this is ending the if, so now we need to end the for. Okay, so whatever order it finds first, it's going to execute that function first. Let's go ahead and work on our rotate function here. Now this guy is a little interesting. I was trying to figure out a way to programmatically take care of this. And so I made this little table here. Let's take a look at it. So one of the things I was trying to do is have an economy of movement. All right, so let's take a look at what I mean by economy of movement. Now let's see, we're facing south. Now let's say we wanted to face west. Well, we would just turn right once. So how do we know? Let's say, for example, we wanted to turn and face east. Well, we could go like this. We could say south and turn all the way around until we're facing east. That's one of the ways we could do it. In other words, you just say from the position you are, you do a little bit of math and just rotate one direction. But I was hoping to be able to save a couple of extra turns. So we needed to have some intelligence to know when we turn left once or turn right once. This is definitely one of those things where there are a lot of different ways to do it. So what I was looking at was the math when you subtract your start coordinate from your end coordinate. And what you end up with is if you turn left, you either are going to do you're going to have a 1 as the difference here. So if we're going from south to south, it's 0, obviously. South to west is 1, or sorry, -1. Turning all the way around is -2. Turning left is 3. So if you see that, I also put a no turn W for whatever, and this is a right turn versus a left turn. So anyways, the math behind it shows that when you take a left turn, you're most often going to do a 1 turn to the left or a 3. So whenever we have this become our difference when we do a subtraction, well, we will go that direction one time. That may not make a lot of sense. So let's go ahead and jump right into it, and that will hopefully help it make sense. So we're going to make a local function. I'm going to call it rotate. And we're going to have a start. We're going to pass in a start and an end. And then the very first thing we're going to do is find the difference. So we're going to have a local diff, and this is going to be the start minus the end. There we go. And now we're going to have a little table. Let's do this. I don't want to hear a sheep in the background. Boink. Go away. Okay. So we're going to have a direction table. Okay, so we'll do a little bit of math here. So if math.absolute of the difference is greater than 0, so in other words, we're definitely turning, then if the diff is -3 or diff is 1, then we're going to have essentially a rotation vector. So how many times we're going to rotate? Once. And which way are we going to go? We're going to go left. So again, corresponding to this table down here, if the difference is 1 And let's see, where's the other one? Here it is, right there. If it's 1 or -3, we're going to turn left. And we're only going to do that once. So else if diff is 3 or diff is -1, so now we're going to do the right turn, then the direction map is going to contain a 1 and R. All right, else our direction map, our direction is going to be a 180-degree turn. So we're going to go twice R. Okay, so let's go ahead and end this, in this little block here. And here is our action. For I equals 0 to the first element of our direction table, we're going to do a turn. I'm going to call our turn function, and we're going to pass in the second part of the table function, or the table element. End. We're going to end our if statement and end. Okay, so does this make sense? Did I make sense? The way this function is going to be used is we're going to give it a start position where we are currently facing and an end position where we want to go. And then we are going to find the difference of those, and we're going to open up a little table here. We're going to populate that table with what we are doing depending on the result of the difference. So we know that if we subtract these and we get a -3 or a 1, we're going to want to take a left. If we subtract these and get a 3 or a -1, then we're going to take a right. Otherwise, we're just going to turn all the way around. And so we're going to use this, this direction table in our for loop here. So going either once or twice, we are going to loop through this direction, turn left or right. Now, I want to add this caveat. I'm certain there are more than one way to do this, for sure. But this is the way that I thought, I guess the way my brain works. And so this is what I come up with. So, and it does work. Okay, let's jump right in and start roughing in our move function, our move X. So let's see, let's go back and have a local function called move X. And okay, so now we're going to have a local vector. Now, a vector, it's a fairly straightforward idea. It's basically a unit of measurement that has both a direction and a magnitude. So it's essentially like if you were to look at the Cartesian plane. The Cartesian plane has two dimensions, x and a y. X is your horizontal axis, y is your vertical axis. If you were to plot put a dot on 1, 1, and draw a line from 0 to that dot, you're going to have both a magnitude, which is going to be 1, and the direction, which is going to be positive. And so if you were to, I guess, put that in some notation, it would be something like this. This would be your vector. And so it's sort of a fancy term, but ultimately what it means is magnitude and direction. And so we're going to be using that idea. And so we're going to have an X vector. And so we're dealing in 3 dimensions, but we're only going to deal in it 1 dimension at a time because, well, the turtle can only move in 1 direction at a time. It can't move diagonally. So we don't have to worry about that. So our X vector, we're going to have the same idea. We're going to have a start and an end. So let's just do this real quick. We're going to have a start our start position, and we are going to have our end position. There we go. Okay, so to do this start position, we need to figure out what our current position is. And so we are going to actually we're going to have another helper function that we're going to use outside of this goToPosition. So it's sort of going to be a helper function. We'll put it down here for now. Call it function copy position. And we're going to pass in a position. So what this is going to do, this is actually going to return another position. So let's go ahead and have copy. And we're going to copy this table. What we're going to do is what's called a shallow copy. You would want to do a deep copy. Let's say, for example, you had this is just a simple table right here. Okay. If you wanted to do a deep copy, you would do a deep copy in the situation where you had something like this. So you have some simple values, but you also have another table as a value. And of course, tables can be nested, I guess, as many times as you want. And especially when you're dealing with 3D space, you might end up having a three-dimensional table. That's a possibility. But we are only going to concern ourselves with a position, which is just a 4-part table. Okay, so for let's see, a table has both a key and a value. If you don't specify the value, if you don't specify the key, it's just a zero-based index. If you do, like we did here, then you can actually call the string as the key if you like. Okay, so what in the world happened there? Key V, KV for key and value, in current position, do. Okay, we're going to copy our key. Sorry, we're going to use the key from this 4 to call each key in in current position. And we're going to assign that to the value of k in copy. And then return copy. Okay, so what that means is for every key value pair in current position, take the key. This is basically getting the value of current position at the key and copy that value to copy this little, I guess we should do this. It's a local. Okay, so our local copy table here, we called it, we called the table copy, and we'll return that. Okay, so let's put that into action. Now remember, our current position is the position that is being maintained with our, let's go here, yeah. It's the thing being maintained by our go function, right? So the go function has been keeping track of the turtle's position. So these values have now changed. The program is running. These are just initializing the values. So say the turtle's been running. It knows what its current position is. So we are going to take that current position and we are going to copy it. So we are going to copy this and we're going to say, we're going to call this our start position. And we're going to use our copy position function. And we're going to pass in the current position. So now we're going to hold what our current position is in this variable we call the start position variable. Okay. Now, back here. So now we have our start position, and our end position is simply going to be the position we want to go to. So let's do this. Oops. Okay, so our x vector is going to consist of our start position of the x value minus the position, so the end where we want to go, using our x, I said x value, I meant x key, which produces the value of x. And there we have our x vector. Using our start position and our end position, when we take the difference, we will have both a magnitude and a direction, positive or negative, and the number will be the number of spaces that the turtle needs to move along the x-axis. So it's really pretty straightforward. A lot of times, the simpler the concept you try to explain, the more difficult it is to explain it. But just harken back to grade school. This is just subtracting numbers. And we're going to use the information we get from the number, both the sign and the actual number itself, to send the turtle in the direction we need it to go. Now, these move functions are going to be fairly complex, so I'm going to actually go ahead and stop here because we want to be able to have, I guess, do this whole move function in as much of a block as possible. And so the episode's already running a little long. So we're going to stop here. And the good thing is, though, once we have the move x function done, we'll be able to do the move y and z fairly easily. And as a matter of fact, we may even be able to do some refactoring and make it one local function that we can pass in an x, y, or z value. So, that might be something we do in the next episode or two. But anyways, if there are any questions, let me know. If there's something that I wasn't clear on, just let me know in the comments. If you are enjoying the series and you like it, give it a thumbs up. Like I said, it always helps. And or if you don't like it, give it a dislike. But I appreciate all of you watching. I hope it's helpful for you. I'm still very excited about the progress we're making. And it's going to be pretty cool once it gets all completed here. So anyways, guys, I will see you all again next time.